Hello folks, I'm going to solve some free fall problems for you, and these will be useful for your problem set as well as for your exam. So here's one. We have an African antelope known as springbok will occasionally jump straight up into the air, and that's a movement called pronk. The speed when leaving the ground can be as high as 7 meters per second. If a springbok leaves the ground at 7 meters per second, so we're looking at a springbok leaving the ground. I'm taking it as a dot for simplicity. With Vy initial is equal to 7 meters per second. A. How much time will it take to reach its highest point? So that's a free fall, but thrown upward. We know that it will go up a little bit and then it will come back down. One important information here: as the object comes back down, its final velocity will be equal to its initial velocity, only in opposite direction. Here I can put minus 7 meters per second, but actually I'm already showing it, it's minus, showing it downward. Remember, the direction, plus minus shows direction for velocity. So it will reach up to a point, it will have a highest point, and at this highest point, its Vy, let's call this Vy top, will be 0. Momentarily stop there. And this is a symmetric motion, folks. As it goes up, it will be spending some time, delta t, and as it comes down, it will be spending the same time. So if we are looking at the total time, I'll call this t tot, it will be 2 times delta t. I already gave you a lot of information that we were going to be asked, but let's answer the questions now. A is asking us how much time will it take to reach its highest point. We can use the velocity to reach that information, and we know that for any free fall motion we have an acceleration that is along y, and that is always equal to minus g. It's again being downward direction, means it's minus. And we know g is equal to 9.8, so it will be minus 9.8. Okay, I'm gonna rewrite that. Minus 9.8 meters per second squared. So A, how much time will it take, can be found using this information. Vy final, this equation. Vy final is equal to Vy initial plus Ay delta t. This is for any accelerating motion along y. For free fall, I'm going to replace my Ay by minus g. That is the only difference. And I'm going to solve for that delta t. Vy initial is 7. It's positive. Remember, along y vertical direction, up is positive, down is negative. And we will calculate that delta t using these informations. To solve for delta t, let's go slow with algebra here a little bit in case you guys are rusty with your algebra. I'm going to leave this term here, take this term to the other side. That's going to go to the other side as minus because it's plus here. Your way of doing this, I deduct Vy initial from both sides, the same thing, and I'm going to have Vy final minus Vy initial is equal to Ay delta t. I'm not replacing Ay but minus g yet, but I will. And then I'm going to solve for delta t. That is working with dividing both sides by Ay, or minus g would be the same thing. So my delta t from here is equal to Vy final minus Vy initial divided by Ay. Now I am putting my values. Vy final here is actually equal to Vy top because I'm considering the motion from here to there to find delta t. Don't confuse it with this Vy final. I hope you guys are fine with that. I don't want to do renaming here. It's going to be more confusing. But I'm looking at the motion from here to there. My VY initial is this. Maybe we'll call this VY final 1 or something, so it will be different than VY final here. So it's VY top, it's equal to 0. VY initial is VY initial 7 meters per second squared, so we'll put here 7 meters per second. 0 meters per second minus 7 meters per second. Initial VY from here divided by, now I'm entering minus g here, minus 9.8 meters per second squared. So I put it in here. Mistake. Take care of that. 9.8 meters per second squared. Over here again, meters per second nicely cancels. You guys don't have to show this or do this. And only 1/2 is left. Inverses become second. I'm looking for the time, so it works perfectly. If my units works, that means I am doing my solution correct. Minuses will also cancel, and I'm going to get my time as a plus time, and that should be, I believe, 0.71 seconds. So that's how much time it takes to reach to the highest point. This highest point, often called H maximum. Let me show it on this side so we won't be making a big mess there. That's a delta y, right? That's already delta y. So what is the highest delta y we can reach? We can call H maximum, and we can calculate it using y equation. B tells us how long will it stay in the air. We already talked about that. We already have this answer. Now we said the first half of the motion, if it is delta t time, the second half will be the same, and we calculated that delta t 0.71 seconds. So the total time t tot, as we put over here initially as we were walking through what we're gonna do, will be equal to 2 times delta t, and that is always the case. So t total is equal to 2 times 0.71 seconds, and that's equal to 1.43, about there, seconds. So let's do what here. And C we also already answered. C tells when it returns to the earth, how fast will it be moving. At the same level, the object always moves with the same speed but opposite directions. So velocities are in opposite direction but magnitudes are the same. So if it started with 7 meters per second on the ground, it will come back to the ground with the 7 meters per second in the opposite direction. So Vy final is equal to 7 meters per second down would be correct answer, or minus 7 meters per second, also correct answer, because we all know we're taking down as negative in this question. There's another one that is very similar to the one we solved in class. A stone dropped from rest at the top of a building as shown in the figure here. We have initial velocity 0, increases to velocity, 3 seconds passed. Shorter version here. Everything is shown in the picture. It hits the floor 6 seconds, so it's looking at continuations of the motion here. So it seems the total time passed, delta t here, is 6 seconds, and hits the floor. That will be our Vy final. I'm going to stick with Vy's here. That's what we've done. V initial sometimes is called as V0, so that's similar thing, initial. So I will call this Vy initial. So we just dropped this ball. how tall is the building? That's what the question is asking. H or delta y. So I'm going to go ahead, stick with our decision to take y initial to be here equal to 0. Then y final will be, well, y final will find it as negative, but we know what negatives means. So the height would be absolute value of y final we'll find from here. And we're going to use this equation. Y final is equal to y initial plus vy initial delta t plus 1 over 2 ay delta t squared. Feel free to directly replace this by minus g for any free falls. So let's write that version of that as well. Y final is equal to y initial delta t minus 1 over 2 g delta t squared equivalent. Now we cancel what are 0. Y initial is 0. Y initial is 0, so that goes away. We'll find y final using this equation. Minus 1 over 2, replacing everything. 9.8 meters per second squared. Time is given 6 seconds. Take square of that. And y final we'll find from here. Let's see what that was. 172.4 meters. So minus 172.4 meters. Again, negative means initial height here is taken to be 0. It's downward. So we can go ahead and just take the absolute value of minus 172.4 meters. So 172.4 meters. Now here I've seen some of you have used to taking this to be y initial. This position to be 0. This position to be 0. And find the height using y initial, then height would be equal to y initial. That's all fine. It should all work. Then you will get y final 0, and you will get your y initial to be positive from this equation. You will set this guy 0. You will calculate that guy. It will not be 0 anymore. You will get it as positive. That's also fine. If you are a quick thinker, you can always say, well, this is 0, this is y final delta y will be giving me height, so I can just go ahead and call this height h instead of saying y final, and I just directly look at delta y. Since this is 0, it will not change anything, right? Delta y will be y in my final minus initial, that is 0, so delta y is equal to final actually. It's also equal to h. Skipping a lot of steps here, folks. If you are not comfortable with this don't use it. But I can go ahead and directly say that height is equal to 1 over 2 gt squared. I don't have to go about all these nitty-gritty because I know this guy is 0, this guy is 0, and that's what it's gonna give me, and so forth. That will be your height always, if and only if your initial velocity is 0. If it's not 0, you have to include this term as well. Alright, enough information, no more confusions for you. Let's move on to the next question here. This one looks quite different, but it's actually a pretty simple question. Passengers on a giant drop, a free fall ride at Six Flags, Great America. I know there are many Six Flags that exist in America. I've seen one in Texas. But anyway, sit in the car that raced to the top of a tower, and then they dropped. So people are sitting. I don't like these type of rides. You know me a bit by now, so I wouldn't be happy. I would never ever sit in that. My kids does, maybe you guys also do. But you're sitting here, so you'll have a height and you're dropped. Since you're dropped, I'm representing you with a dot now, you'll have initial velocity 0. And you'll be dropping free fall. I don't know what is the fun with that. People likes getting scared, I guess. The cars are then released for 2.6 seconds. So you drop for 2.6 seconds. The time you drop is given. How fast are the passengers moving at the end of the speed and up phase of the ride? So you will be gaining a vertical velocity Vy final. And the question is asking you, what is that? Notice we are following all the question solution techniques. We draw a picture, we put what is known in the picture, which is how I like doing it. It gives me a good idea of what is happening. And then we say what is asked for us, which is also in the picture here. And here's what we will use. I'm sure you guys can now easily do this, but Vy final is equal to Vy initial plus Ay delta t. Put minus g here. Feel free, guys, to directly jump into this version. Vy initial minus g delta t. Right? So Vy final will be, this guy is 0, so I'm dropping it. Minus 9.8 meters per second squared times delta t was 2.6 seconds. And that's it. The value should be 25.48. And as I've told you before, I include up to 2 decimals. It will be meters per second. And it's negative. I already knew that it's negative because it's downward, right? So I can say it's negative 25.48 meters per second, or I can say Vy final is equal to, magnitude is 25.48 meters per second, and it's downward. Okay, that's all for the questions on free fall. I'm gonna post these as annotated free fall, so it will be updated if it was already there. All the works I'm showing here will be posted on Engage as well as the videos. Good luck.